This video is going to cover section 1.1, definitions of statistics, probability, and key terms. The science of statistics deals with the collection, analysis, interpretation, and presentation of data, which is factual information. We see and use data in our everyday lives. And here in figure 1.2 from our textbook, we see a dot graph of the frequency of average time in hours spent sleeping per night. So each dot represents one data point, and it's graphed on the number line, so we can see that there's a high between 6 and 7. We can see that there's data points at 5 and 9, which are on the outside edges. And this visual gives us a good way to look at our data. We see this kind of thing all the time. Organizing and summarizing data is called descriptive statistics. Graphing and using numbers, like an average, are two ways to do this. Inferential statistics uses formal methods to draw conclusions from good data and probability to determine how confident we can be that our conclusions are correct. Probability is a mathematical tool used to study randomness. It deals with the chance, the likelihood, of an event occurring. For example, if you toss a fair coin 4 times, the outcomes, which is called the experimental probability, may not be 2 heads and 2 tails. However, if you toss the same coin 4,000 times, the outcomes will be close to half heads and half tails. The expected theoretical probability of heads in any one toss is 1/2 or 0.5. Even though the outcomes of a few repetitions are uncertain, there is a regular pattern of outcomes when there are many repetitions. A population is a collection of persons, things, or objects under study. To study the population, we select a sample. The idea of sampling is to select a portion or subset of the larger population and study that portion, the sample, to gain information about the population. Data are the result of sampling from a population. From the sample data, we can calculate a statistic, which is a number that represents a property of the sample. A parameter is a numerical characteristic of the whole population that can be estimated by a statistic. For example, all stats classes are the population. Our class is a sample. Our average grade is a statistic, which is an estimate of the parameter of all average grades earned by students in stat classes. One way that I remember this is that statistic and sample both start with S, and parameter and population both start with P. So I know when I'm talking about a statistic, I'm talking about the sample, and when I'm talking about a parameter, I'm talking about the population. How accurately the statistic represents the parameter is very important and depends on how well the sample represents the population. The sample must contain the characteristics of the population in order to be a representative sample. A variable, usually notated by capital letters such as X and Y, is a characteristic or measurement that can be determined for each member of a population. Variables may be numerical or categorical. Numerical variables take on values with equal units such as weight in pounds and time in hours. Categorical variables place the person or thing into a category. Data are the actual values of the variable. They may be numbers or they may be words. Datum is a single value. Two words that come up often in statistics are mean and proportion. Mean and average are often used interchangeably and is really the arithmetic mean, which add together and divide by the number of data to get the arithmetic mean. Proportion is the relation of the part to the whole when describing data. For example, in a class of 40 students, 22 are men, so the proportion of men in the class is 22 over 40, or 22/40ths. Example 1.1. Determine what the key terms refer to in the following study. We want to know the average, the mean amount of money spent on school uniforms each year by families with children at Knoll Academy. we randomly survey 100 families with children in the school. 3 of the families spent $65, $75, and $95 respectively. You can find these examples in the textbook as well. So what is the population here in this example? It's going to be families with children at Knoll Academy. What is the sample? It's going to be the 100 families surveyed. So they're kind of the same, right? They're similar because the sample comes from the population. What is the parameter? So the parameter, again, deals with something from the population. So it's the mean amount of money spent on uniforms, and you could even say by families with children at Knoll Academy. So the statistic is going to be the same kind of as the parameter, but it's going to relate to the sample. So the statistic is the mean amount of money spent on uniforms by the 100 families surveyed. What's the variable here? The mean amount spent on uniforms by one family, so that's the thing that we're going to go out and ask and find out about. And then the data are going to be the individual values, so they're the dollar amounts spent by the families on uniforms. In this example, they would be the $65, the $75, and the $95. Example 1.2. Determine what the key terms refer to in the following study. A study was conducted at a local college to analyze the average cumulative GPAs of students who graduated last year. Fill in the letter of the phrase that best describes each of the items below. So we're going to look for the population, the statistic, the parameter, the sample, the variable, and the data. A is all students who attended the college last year. B is the cumulative GPA of one student who graduated from the college last year. C is 3.65, 2.80, 1.50, 3.90. D is a group of students who graduated from the college last year, randomly selected. E is the average cumulative GPA of students who graduated from the college last year. F is all students who graduated from the college last year. And G is the average cumulative GPA of students in the study who graduated from the college last year. There's a lot going on this slide. And one of the things I don't love about this example is that they don't sort of go in the order that I think of. When I think of this kind of problem, I would go population, then sample, then parameter, and then statistic to sort of keep it organized in my head. But this one sort of does it a little bit differently. So again, we're looking for the cumulative GPAs of students who graduated last year. And that part is important. So when we're talking about what is the population here, we want to be thinking about the students who graduated. So the population is going to be F, all students who graduated from the college last year. So now the statistic is going to be related to the sample. So we want to think about that piece of it here, and it's going to be G, the average cumulative GPA of students in the study who graduated from the college last year. So the in the study piece is important there. The parameter here, so again, the parameter has to do with the population, so it's going to be E, the average cumulative GPA of students who graduated from the college last year. The sample, so this is going to go back to being related to the population, but it's going to have to do with our study. So D, a group of students who graduated from the college last year, randomly selected. The variable, so that's going to be sort of the question we're asking or the thing we're looking for. It's going to be B, the cumulative GPA of one student who graduated from the college last year. And then the last thing is the data. In this case, it's C, 3.65, 2.80, 1.50, 3.90. So the specific values of GPAs of the students who graduated, or individual students who graduated from the college last year. Example 1.3, determine what the key studies refer to in the following study. As a part as part of a study designed to test the safety of automobiles, the National Transportation Safety Board collected and reviewed data about the effects of an automobile crash on test dummies. Here is the criterion they used. They looked at the speed at which cars crashed, the location of the drivers, i.e. the dummies. 35 miles an hour was the speed they used, and they looked at, so speed at which cars crashed was 35 miles per hour. The location of the drivers was the front seat. Excuse me about that. So cars with dummies in the front seats were crashed into a wall at a speed of 35 miles per hour. We want to know the proportion of dummies in the driver's seat that would have had head injuries if they had been actual drivers. We start with a simple random sample of 75 cars. What is our population here? All cars with crash test dummies in the front seat. What is our sample? The 75 cars from the simple sampling. What is the parameter that we are looking for? The proportion of dummies with head injuries. Statistic, now remember this has to do with the sample, so the proportion of dummies with head injuries in the sample. What's the variable? So this will be more individual. X, remember we use X or Y when we're talking about our variables. Whether a dummy would have suffered head injuries. And what is our data in this situation? Yes, the dummy had a head injury, or no, the dummy did not have a head injury. And what kind of variable are we collecting here? Is it numerical or categorical? Well, if our data are yes or no, then it's really categorical. We can talk about it in a numerical way with a proportion, how many had head injuries versus how many that didn't. But since we're collecting yes or no, the data is categorical. Example 1.4. This is our last example. Determine what the key terms refer to in the following study. An insurance company would like to determine the proportion of all medical doctors who have been involved in one or more malpractice lawsuits. The company selects 500 doctors at random from a professional directory and determines the number in the sample who have been involved in a malpractice lawsuit. What is our population here? All medical doctors in the professional directory. So it's important to read the problem fully to understand sort of the boundaries of what we're talking about. What is the sample? So very similar to the population, but a little tweak, the 500 medical doctors selected at random from the professional directory. What is our parameter? Again, this is related to our population. So it's the proportion of medical doctors involved in a malpractice suit in the population, which was all medical doctors in the professional directory. What is our statistic? This is related to the sample. So it will be the proportion of medical doctors involved in a malpractice suit in the sample. The variable in this situation, X, whether an individual medical doctor was involved in a malpractice suit. So again, the variable tends to be an individual type of thing. And then what is our data? Yes, involved in a malpractice suit, or no, not involved in a malpractice suit. So that is our section 1.1 information, and that is